your own users to log in and register, to buy and sell stocks, so to speak, using virtual currency. So over the course of the class's several months, will you go truly from building a pyramid in Mario to building your very own web application and more, followed by the course's capstone experience, which will be your very own final project. But what exactly is computer science? What we thought we would do in this week 0, the very first week of the class, is consider exactly what it means to solve problems. And let me propose that this is computer science. This is problem solving. You have some input, which is the problem you care about, that you want to solve, and you care about the solution to that problem, which is the so-called output. And in between that input and output is this black box of sorts, inside of which is sort of the magic that happens, the magic that you'll eventually be able to harness and compel computers to solve problems for you. Inside of that black box ultimately is going to be the code that you write. But for us to begin doing that, we all kind of need to agree on how we're going to represent these inputs and outputs. We all kind of have to speak a common language, so to speak. And so we need to agree how these inputs are going to be represented. So how might we typically represent information? Well, maybe the simplest thing to do at the very first class, whether we're online or in person, is to take attendance or to count the number of people in the room. And so you might do this old school style on your hand so as to represent every person in a room with just a finger raised on your hand. So how we might represent information boils down to very simple digits on your hand. Of course, you can't count very high with just this hand, but there's actually a fancy word for what we're doing old school here, and that's unary notation. Uno implying one, or one finger being up or down. And so you can count, it would seem, as high as 5. And of course, if I bring in a second hand, I can go as high as 10, and then things get a little more difficult. But it's a system for representing information, and it's fairly universal, certainly when we're all quite young. But you and I tend to use a more useful system, not just digits on the hand, but other sorts of digits, namely the decimal digits that you and I know. So the numbers that are otherwise more technically called base 10, and that's just a fancy way of describing the fact that there's 10 digits that you and I as humans really tend to use typically. And those digits, of course, are 0 through 9. And using these several digits, we compose numbers like 0 through 9, but also 10 and 11 and 12 and as high up as we want to go by using multiple digits still. But computers don't really speak the same language as us. They're, in some sense, much simpler than we humans, even though they seem so complicated or so sophisticated and certainly so fast. At the end of the day, these are all human-made devices, and they're relatively simple at their core. In fact, even if you don't quite know what you're saying, but you've at least heard this to be the case, what language do you understand computers to speak? What language do computers speak, if not the system that you and I use of 0s through 9s or decimal? Brian, could we see who might answer this? What system do computers use, so far as you've heard, whether or not you've taken a CS class before? Keith, can we go to you first?
Yeah, the computers use binary.
Binary. And can you elaborate a little bit? What do you mean by binary?
It's 0s and 1s. So like while we use 0 through 9 for base 10, it uses 0 through 1 for base 2.
Yeah, exactly. So computers use the so-called binary system, bi implying 2, and they indeed only use, as Keith notes, 0 and 1, 2 digits. So on the one hand, this is actually pretty encouraging because, wow, this is actually a pretty simple system if we're only using 2 of these digits. But of course, if you only have 2 digits, how are we going to represent the number 2 or 3 or 4 or any much larger number? It would almost seem like a step backwards. But it isn't actually. And it turns out that this so-called system, or base 2 because there's 2 digits in the vocabulary, otherwise known, as Keith says, as binary, uses just 0s and 1s. And it turns out there's other nomenclature here we can toss out. These 0s and 1s are otherwise known as bits. And bits actually derive from just 2 words, binary digits. Binary implying 2 possibilities, digits just being symbols on the screen. So binary digits are otherwise known as bits, and computers speak binary using these things called bits. But what does that mean, and why is it the case? Like, why didn't they invent computers decades ago that just use 0 through 9 rather than come up with a whole new system for us to think about, let alone talk about? Well, at the end of the day, computers are using what as their input? Really just electricity, right? Probably the only thing all of us do every day or every couple of days with our laptop or desktop or phone is either make sure it's still plugged in, or 2, plug it in so as to charge it. So the only physical input to our devices these days is electricity in some form. And we don't have to get into the nuances of what electricity is, but I think it's about electrons flowing into the device so as to charge it. So it suffices for our purposes to know that there's some physical input to the device. these computers and phones that we use. But that's it. And so if we harness this electricity, maybe we can start to represent information with it. For instance, here is a light bulb, this old ghost light in the theater here that's currently off. But it has the ability to turn on. We just need to plug it in or throw on a switch. And if that's the case, what's really quite compelling about the metaphor of using lights is that right now this light bulb is currently off. But as soon as I allow electricity to flow, as by plugging it in or maybe throwing a switch, now it's, of course, on. And if I unplug it or throw the switch again, it's off. Or if I plug it back in, it's on. And the implication of this very simple idea is that we can take a physical device like a single light bulb, and by plugging it in or unplugging it, we can represent information. What did I just do? I represented the light bulb being off or on, but we can just call off and on something else. We can call them zeros and ones. And so this